Consider a two-stage reciprocating air compressor with a perfect intercooler operating at the best intermediate pressure. Air enters the low pressure cylinder at 1 bar 27 degrees centigrade and leaves the high pressure cylinder at 9 bar. Assume the index of compression and expansion in each stage is 1.4 and characteristic gas constant for the air is 286.7 joule per kg Kelvin. The work done per kg of air in the high pressure cylinder is. So here it is a two-stage reciprocating compressor with a perfect intercooler. Here perfect intercooler is nothing but, in case of perfect intercooler, the intermediate pressure is given by root of P1 into P3. Let us say P2 is the intermediate pressure and P1 is the initial pressure, that is pressure at the entrance pressure at the low pressure cylinder, and P3 is the exit pressure at the high pressure cylinder. So here P1 and P3 are known values, that is P1 is 1 bar and P3 is the 9 bar. So here P3 is the pressure pressure of the air at the exit of the high pressure cylinder, so that is 9, and P1 is 1, so which gives 3 bar. So this is the intermediate pressure of the two-stage cylinder, two-stage compressor. So we know that the work done by the compressor is equal to gamma by gamma minus 1 RT into P3 by P2 power of gamma minus 1 by gamma minus 1. So this is the work done by the high pressure cylinder, that is, sorry, not work done by the work done on the cylinder, because it is a compression process, so that work done on the cylinder is equal to this is. Even P3 by P2 is the ratio of the ratio of P3 by P2 is equal to 3. Even the ratio of P2 by P1 also 3. So that the work done for either cylinder is same and is equal to gamma by gamma minus 1. That is, gamma is nothing but the compression index, that is 1.4, and R is 286.7, and T is the initial temperature 27 degrees centigrade, that is 300 Kelvin, and P3 by P2 is 3, and here it is 0.4 by 1.4 minus 1. So it gives a value of nearly 111 kilojoules, that is 111 kilojoules. So in the option, the right option is A. A is the right option. Suppose if he asks about the total work done by the two cylinders, then it is equal to 2 into 111, that is 222 kilojoules. So shows pressure and velocity variation for. So here the pressure and velocity variations are given. So we will have to find out whether it is velocity compounding or pressure compounding or velocity pressure compounding. So it is a pressure compounding turbine. So the given variation shows represents pressure compounding. So in the option, the right option is B. B is the right answer. The annual consumption of an item is 2,20,000 units. Ordering cost per order is equal to 100 rupees. Carrying cost per unit per year is equal to 0.25 rupees. Calculate the ordering cost per year when UQ is being ordered every time. Here ordering cost is given by R C0 CC by 2, where R is the annual consumption or annual demand, that is 20,000 units per year, and CO is the ordering cost and CC is the carrying cost per unit per year. So here R is equal to 20,000 and ordering cost is 100 and it is 0.25 by 2, which gives a value of 500 rupees per year. So in the option, the right option is C. C is the right answer. The shaft shown in the figure is subjected to torsion T at 2 points A and B. The torsional rigidity of portion CA and BD are GJ1 and that of portion AB is GJ2. The rotations of shaft at points A and B are θ1 and θ2. The rotation θ1 is. So here is the given diagram. Here it is a compound shaft which is subjected to twisting moment at 2 points A and B. These are the 2 points A and B and of magnitude of T. So here we know that the rotation theta is generally given by TL by GJ. So here we will have to find out the rotation at point A, that is theta 1. So here either we will have to come from the right side or either we will have to come from the left side. If you come from the left side, in between C and A, it is equal to theta CA is equal to TL by GJ CA. So here in the shaft CA, the torque is equal to T and length is equal to L, and GJ is given by, the torsional rigidity is given by GJ1. So that is TL by GJ1 and is equal to theta 1. So the right answer is TL by GJ1, and in the option the right option is B. B is the right answer. Moment diagram for a beam is given below. So here is a bending moment diagram, and here we will have to find out the shear forces at AA and BB respectively are of the magnitude. So here the portions A and BB are as shown here. Here it is at 0.5 meter from the left end and BB is 1 meter from the right end. And here there are two known values, 100 kilonewton meter and 200 kilonewton meter. These are the bending moment values. So here we will have to find out the shear forces at AA and at BB. So we know that the shear force is nothing but the rate of change of bending moment with respect to the X. So here in between at the portion AE, so here at the portion at the section AA, here the bending moment is constant over 1 meter span. That means the shear force is 0 here. There is no change in moment, so that over the portion at the section AA it is 0, and at the section BB it varies linearly from this point to this point. That is in our 2 meter span, the bending moment varies linearly with X. That means in between these 2 points the shear force is constant, and we can have so again F is equal to dm by dx, that is 200 minus 100 by 2, which is equal to 50 kilonewtons. Or we can have we can get the bending moment at the section BB, that is it varies linearly, so that's why it is equal to 150, and in between these 2 points, that is over the span of 1 meter, we can calculate the shear force, that is equal to, let us say 150 minus 100 by 1. So it also gives 50 kilonewton. So in the option the right option is 0 and 50 kilonewton, and the right option is C. C is the right answer. Manufacturing a product requires processing on 4 machines A, B, C, D in the order A, B, C, D. The capacities of 4 machines are A is equal to 100, B is equal to 110, C is equal to 120 and D is equal to 130 units per shaft. If the expected output is 90% of the system capacity, then what is the expected output? So here coming to the solution, expected output is nothing but it is equal to minimum capacity of the machine into expected output efficiency, that is the product of minimum capacity of the machine and expected output efficiency. That is expected output is equal to the minimum capacity of the machine is in the 4 options, the minimum capacity of the machine is A and has 100 units and efficiency is 0.9, which is equal to 90 units. So in the option the right option is A. A is the right answer.